In the next set of examples for graphing inequalities, we are now going to be working with inequalities that have two variables. Now, just because we change from one variable to two variable does not mean that the process changes. We're still going to go through our 4 steps. And in the process of doing this, we will end up creating an inequality, but this time without horizontal or vertical lines. So if you need a quick refresher, maybe go back to the previous lesson and review how to graph lines in Slope-Intercept form and review how to graph lines in standard form so that you will be comfortable doing the first step of the inequalities, which is graphing the actual line. Okay, I'm going to take you through example number 2, part A, and then I'll go through part B as well since it's a different form, and then you can work the examples after that. So let's take a look here first. In example number 2, the very first thing we have to do is we need to rewrite this as an equation of a boundary line, and so we're going to rewrite this as y equals 2x. Now, if you notice, we don't have anything added to the 2x, but if you want to make it easier to see the slope-intercept form, you could technically write plus 0. And then you could see the y equals mx plus b form. And of course, to graph this, I would just plot 0, 0, and I'd go up to over 1, or I could go down to and over 1, just like I learned how to graph a line in slope-intercept form. And now I need to draw the line, and I have to pay attention to whether I'm doing a dashed or a solid line. And since it's not equal to, it's going to be a dashed line. And so freehanding that the best I can. We get to the third step, which is to test a point. And if you notice, in previous examples, we're always testing the point 0, 0 because it's easy to calculate. However, for this particular example, 0, 0 is actually going to be on the line, so we cannot use 0, 0 as a test point. That's not going to help us decide which side of the line to actually shade on. So I'm going to just pick a random point on either side of the line that's not on the line, and of course this example uses 1, 1. Now, here's the second point about testing in two variables. We need to know which one of the variables actually represents an x and a y, which value represents x and y, and so I can plug this into the inequality. And through this process, I get the value 1 is less than 2, which is a true statement, and so that means that 1, 1 lies in the shaded area because it would lie in the area on the side of the graph that has all of the solutions, and since it's a true statement, it's considered a solution. And then we would simply come in here and shade in all the parts on that side of the line. So you can see that the process here is exactly the same as it was before. Now we're just dealing with more complicated lines. Now, part B has us in standard form. So if you recall standard form, first thing we need to do is change this to a line, and we need to graph this line. Now, you could graph this line by the use of slope-intercept. You could move everything to one side and get y equals, or you could use the x-intercept and y-intercept, and so you could t-chart a value 0 of x, and you could t-chart a value 0 for y, and in the process of doing that, you're going to get the point -2, and then you're also going to get 5, 0, and you can see here we would plot that point and plot that point. And of course it's equal to, so we're dealing with a solid line, and so we would graph that line right there. And again, we need to test the point. This time, however, 0, 0 is not on the line, so I could test the point 0, 0, and I'm going to do that by replacing the x and the y value with 0, and so anything times 0 is just 0. So is 0 greater than or equal to 10? We know that that is a false statement, and so since 0, 0 is right here, none of this would be shaded. We're going to shade everything on the opposite side of the line from 0, 0. And so that's just two quick examples of how to graph inequalities with two variables, one in slope-intercept, one in standard form. Now what I'd like you to do is to go ahead and move on down to sample problem number 2, part A and B. And I'd like you to go ahead and stop the video at this point and work those two problems. first things first, part A. Let's look at part A. My first step is to convert this to an equation so that I can see my boundary line. And so I'm going to say y equals x, and of course that's the same thing as x plus 0 if I want to get it in slope-intercept form. So I'm going to graph the line y equals x plus 0. First thing I need to do though is just take a look to see if I'm graphing a dashed or a solid line. So in this case, since it's not equal, it's going to be a dashed line. And so then I'm going to say y-intercept of 0, 0, and this is an understood slope of 1, which is up 1 over 1, up 1 over 1. Could go down 1 and back 1. And we're going to get our points to graph the line. Now this is going to be a dotted or dashed line, so I'm going to do my best to freehand that. You should be using a straight edge. You'll be using your ID as your straight edge when you do the graphing. I've got the line. I've got a dashed line. Now I just need to test a point. Again, we run into a problem here with the fact that 0, 0 is on the line. And if you recall from the example, we used the test point 1, 1. That happens to be on the line as well. So I need to go somewhere else and just test a point that's clearly not on the line. And so what I'm going to do is I'm just going to come out here and I'm just going to test, some random point out there. And so let's just say 2, 0. 2 zeros is as good a test point as anything else. Now I'm going to replace the x and the y in the equation with a 2 for the x and a 0 for the y, and so I'm going to have 0 is less than 2. And so 0 is less than 2 is actually a true statement. So that tells me that that point 2, 0 is part of the shaded region. It is in the area of solutions that make this true. So I'm going to take my little highlighter function and just do the best I can to stay on this side of the line to represent all of the solutions to this inequality. And so that is the answer to that problem. That graph with the shaded part is the correct answer to graphing this inequality. Let's do part B. And so for part B, we're going to, again, we're going to graph this for a line of 2y plus 2x equals to 4. Now, if you don't like the 2's here, since you have basically a common multiple all the way across, you can actually divide these 2's out, giving you y plus x equals to 2. And of course, that would be real easy to convert to slope-intercept form. And so you could see here we could simply graph the positive 2, and then it's a negative 1 for slope, so it's down 1 over 1, down 1 over 1. And I could graph that line, and we can see here that this is going to represent a solid line. Now, maybe you didn't do it that way, maybe you use the intercept form, so I'm going to come down here and go ahead and do the calculations for intercept form. And what I'm going to do for intercept form is I'm just going to evaluate the equation for x equals to 0. So I'm going to say 2 times 0 plus 2y equals 4. So that's 2y equals 4 and y equals to 2. And then I'm going to plot a second point. This time I'm going to make y equal to 0. So I'm going to have 2x plus 2y. Excuse me. I got to replace the y this time. Apologize. Equals to 4. And then I'm going to say that 2x equals to 4 and x equals to 2. And so if I come back up here, you can see from the previous time, I actually graphed these points already. 0, 2, which is right there. 2, 0, which is right there. And then all I need to do is draw a solid line. Whoa, that's not a very good line, is it? So obviously you need to be working with a straight edge. And I apologize for the terrible line, but it serves a purpose for right now. So let's move into testing a point. Now we can clearly see that 0, 0 is not on the line, so we're going to test the point 0, 0. So I'm just going to use this extra space down here. So if I test 0, 0, I'm going to replace the x and the y with 0, and then that's going to give me 0 is less than or equal to 4, which is a true statement. And so since that is a true statement, it will be part of the shaded region. and you can see that would be our answer. So that finishes up graphing inequalities. Hopefully you did well on that. If you have any questions, please jot them down and ask your teacher in class.